Let's look at the proof of the sum of an arithmetic series. The sum of the first n terms of an arithmetic series is given by Sn equals to n over 2 brackets 2a plus n minus 1 in brackets times d and then close brackets. So for this proof, we're looking at the sum of the first n terms of an arithmetic series, which we label as Sn. Now in this series, the first term is labeled as a, and to work out the next term, we add on a common difference, which we label as d. So the next term after this would be written as a plus d, and then to work out the next term after this, we would add on d here to give us a plus 2d, and then this would repeat. So we can add on an ellipse to indicate that there are terms in between. Now if we consider the position of each of these terms and the multiples of d that we have, there is a nice relationship. So in the first term, we can see that we just have a, and the multiple of d would be 0 because there are no d's here. In the second term, we have a plus d, and so the multiple of d here is 1. In the third term, the multiple of d is 2. In the fourth term, the multiple of d would be 3, and so on. And so the relationship is that the position of the term, if we subtract 1 from it, we get the multiple of d in that term. So in this case, the second term, the multiple of d is 1. The third term, the multiple of d is 2. So suppose we wanted to consider the n minus second term, the n minus first term, and the nth term. For the n minus second term, we start with a, and then we add on a multiple of d here, which is 1 less than the position. N minus 2 minus 1, which gives us n minus 3 in brackets, and then we times by d. To get the n minus first term, we have again a plus, and now to get the multiple of d, we take away 1 from the position. So n minus 1 minus 1 gives us n minus 2, and then we times by d. Finally, to get the nth term, we have a, and then we add on 1 less than the position here, which gives us n minus 1 in brackets times d. Now for this proof, we're going to write the same series, Sn, but this time we're going to reverse the order. And so the first term is now going to be the last term that we had up here, which is a plus n minus 1 times d. And then the second term is now going to be a plus n minus 2 times d. And the third term is going to be a plus n minus 3 times d. And then the terms in between we're going to indicate with an ellipse. And then we add on now the third term, a plus 2d. And then for the penultimate term, we have a plus d. And then finally for the last term here, we're going to have a. Next step is now to add these two series together. So on the left hand side, Sn plus Sn gives us 2 lots of Sn, and then we get the following. So if we add the first terms here together, a plus a gives us 2a, and then we have plus n minus 1 times d. For the second term, we're going to have a plus a again, which is 2a, and now we're going to have d plus n minus 2 times d. So essentially, we're adding 1 to the bracket here. So n minus 2 plus 1 gives us n minus 1, and then we times by d. For the third term, we have a plus a, which is 2a, and then 2d plus n minus 3 times d. So again, we're just essentially adding 2 to the bracket here. N minus 3 plus 2 gives us n minus 1 times d. And then we have the ellipse to indicate the terms in between. Now likewise, all of these terms are going to give us the same result. A plus a gives us 2a, and then n minus 3 times d plus 2d is n minus 1 times d. And then for the penultimate term, a plus a is 2a, and then n minus 2 times d plus d gives us n minus 1 times d. And then for the last term, we have a plus a, which is 2a, and then we're going to add on n minus 1 times d, which gives us the same result as all of the other terms. Now, since we're looking at the sum of the first n terms, we know that on the right hand side here, there are n terms in total. And so we can now think about this as the same term being added to itself n times. So one way to help us understand this is if we had the number 2 and we add it to itself 4 times, this is the same as 4 times 2. where 4 is the number of 2's that we have here. So likewise, using that logic, we end up with 2 times Sn, which equals to 2a plus n minus 1 times d multiplied by itself n times. You can write this as n multiplied by 2a plus n minus 1 times d. And so the final step is to divide both sides by 2, which gives us Sn equals to n over 2 times, in brackets, 2a plus n minus 1 times d, and then close brackets. This is the proof of the sum of the first n terms of an arithmetic series.